Now let us add two angle components together. A football player runs 30 meters at 45 degrees north of east and then 30 meters at 125 degrees RCS or Cartesian angle. What distance did he run, and what is his displacement from his starting point? Well, the first part is simple because distance is a scalar quantity, and all we need to do is to add the two numbers together. So 30 meters plus 30 meters. Because it's a scalar quantity, we do not take into account the angles. So the distance that he runs is 60 meters. Part B, what's his displacement? Now, because displacement is a vector quantity, we now have to take into account the different directions. First, let's make a sketch of the situation. First, he runs 30 meters at 45 degrees east of north. So our first sketch should look something like this, 30 meters. And his second run, 30 meters again, but 125 degrees RCS. 125 degrees RCS is approximately 35 degrees west of north. So it should look something like that. So at the end of the day, we need to find this resultant arrow. Remember, when we add vectors, we add tail to tip. That means we draw the tail of the second vector at the tip of the first vector. Okay, now when we're adding two different vectors together, I like to use a table to keep things organized. So our first vector is 30 meters. Let's convert this to RCS. 45 degrees north of east is really 45 degrees RCS. And our second one, 30 meters at 125 degrees RCS. The x component of both of these vectors is simply the cosine value multiplied by the distance. So 30 meters cos 45, and this one is 30 meters sine of 125. And the y value is merely 30 meters sine 45 and 30 meters sine of 125. So we've broken both vectors into their components. Let's add the components together. So we're going to add or sum, and when we do the math, we find that the sum of the x components is 26.54 meters, and the sum of the y components is 45.79 meters. Now, we've just only figured out the components. We need to use Pythagoras' theorem to put those components back into one vector. However, let's draw another sketch to highlight the situation. So our x component, 26.54 meters, it should look something like this, 26.54. And our y component, 45.79, should look something like this. Now these arrows are not drawn precisely to scale, although this y arrow is longer than our x arrow. And we need to find the resultant vector of that. So we're going to use Pythagoras. V equals the square root of 45.79 meters squared plus 26.54 meters squared, square root. V equals 52.9 meters. And to find the angle, we need to find this angle, and we're going to use a tangent function. The side that is opposite to that angle is 45.79. So we're going to set up our equation. Inverse tan of 45.79 over 26.54. And our angle is 60 degrees. So our final answer is the football player runs 53 meters at 60 degrees RCS.